add an application to a non-homogeneous vector differential equation. And you guys, here is my application. I don't know if I did a good job with a pen there. Shoot.
Oh, the caps are changed again.
Yes, they are. Oh, I've got one. Thank you. I appreciate it. So you guys, let me take a peek at this application. You guys, I hope you don't mind.
So many freaking.
I did not recently type this up. This is an example I typed up from last semester. So I don't remember the example. I don't know the solutions applied. But let's dive in. 2 tanks, each consisting of 10 liters of solution, consisting of a pollutant dissolved in water. Let me draw the 2 tanks. Each again contains 10 liters of solution. Now, a solution containing 3 grams per liter of pollution flows into tank 1 at a certain rate. So here I am flowing into tank 1. At a fluid rate of 3 gallons per liter. However, if the pollution is at a concentration of 4, excuse me, I misspoke, didn't I? That is the concentration. The fluid flow of water is going to be at a rate of 4 liters per minute. And the solution in tank 2 flows out of the process at exactly the same rate. So the rate's going to be 4 liters per minute. However, it is the case that solution flows into tank 1 from tank 2. So let's say into tank 1 from tank 2 at a rate of 1 liter per minute. And solution flows in the opposite direction, that is to say from tank 1 to tank 2. At a rate of 5 liters per minute. Now, initially, tank 1 contains 50 grams of solution, whereas tank 2 initially contains 10 grams. Do you mind if I skip that for now? I'll come back to that. You guys, I think that's my setup. And the actual question is find the amount of this pollutant in each of the tanks at time t. And so let me just think of the amount of solution in tank 1 at any time t as can I just be consistent with my notation? If I call it x1 at t, and the amount of solution in tank 2 at time t, I'll call x of 2 at t. Now, I think this process could easily be mathematically modeled using vector differential equations. And you and I had enough practice with tanks and single tank processes like this. So let's see if we can build an equation. Since I know something about fluid flow, let's talk about fluid amounts in each tank. In tank 1, how much fluid is actually net leaving the tank? Because tank 1's fluid is decreasing at what rate? 1 liter. How much?
5.
I can't hear you.
4 liters.
No, the net change.
0.
That's nothing. I think the amount of water, fluid is staying constant.
Yes.
Is that happening in tank 2?
Yes.
Yeah, it is. And so I think the fluid levels are not going to be changing over time t. However, I do think I can talk about the rate at which the amount of pollutants in the first tank is changing with respect to time. And I think that x1 prime at t. You guys, that's the derivative of a scalar value function. It's not a vector. And I think the fluid is changing at a certain rate. For example, I think coming in, I got a fluid flow at 4 liters per minute. And a concentration of 3 grams per liter. Well, you guys, my units are looking pretty decent. My liters are going to cancel, and I'm just looking at units of grams per minute, which really is a rate at which the amount of pollutant is changing in tank to time t, at least from that particular spout, that pipe. However, if you take a peek at the fluid flow of 5 liters per minute, that's leaving the tank. So I'll subtract off the fluid flow of 5 liters per minute, but I need to multiply that by the concentration of the pollutant in the tank number 1. What is that concentration?
X1T over 10.
Yeah, X1 over 10. I agree. By the way, in case I'm making you nervous, let's put it in units. X1's measured in grams. 10's measured in liters. My liters still cancel as units. I'm being consistent. I think I need to add to this the fluid flow coming in from tank 2, but that's going to be 1 liter per minute. It's just that I need to multiply by the concentration of pollutant in the second tank. That would be nothing more than X2 over 10. By the way, units here, grams per liter. Still being consistent with my units. I think when it comes to the rate at which the pollutant is changing in the second tank, here too, you guys, just look at how much is being added in. And coming in from tank 1, that would be 5 liters per minute. Times the concentration, which clearly is. You know, sorry, it's not very clear to me, is it? It should be an X1 over 10. I am going to subtract from this the fluid flow of 1 liter per minute. Multiply by the concentration of the pollutant in the second tank, but that's just X sub 2 over 10. And you guys, lastly, I need to add nothing. I'm going to subtract off my 4 liters per minute times the concentration, which is X sub 2 over 10. I agree. Okay, you guys, so it's a mess what I'm writing on the input board. Let me clean this mess up. Rewriting my 2 equations, that become an x1 prime of t. Is that going to be, is that a negative 5? Oh, excuse me, I must spell it. Negative 1/2 x1, x1. Is that a plus?
For your middle term right there, the 1 liter per minute times for x2, right there, yeah. Is that supposed to be, how did you get the grams over minutes?
Because I think x of 2 is the number of grams of pollutant tank 2 of tank T.
Should be over.
Is that 10 liters?
Oh, my apologies, that is 10 liters, yes. Sorry, I'll put it back. And I think my first equation cleans up too. You guys help me with the arithmetic. So negative 1/2 x1 plus a 1/10 x2. Or is that a lingering plus of positive 12? Whereas my x2 prime ends up being nothing more than, cheaper is positive 1/2 x1. Is that a minus 1/2 x2? And I do insist that this particular system of equations, it can be mathematically represented with a single vector valued equation. X bar prime being equal to A times X bar plus a B bar, where A is simply equal to this matrix. It's a 2 by 2, namely negative 1/2, 1/10, 1/2, negative 1/2. And my B bar is nothing more than a column vector consisting of entries 12 and 0. So do you guys agree with my VDE representation?
Yes.
And if you do, let's talk about our techniques for solving such VDEs that are non-homogeneous. We stick to the homogeneous one first. And so solving the corresponding underlying homogeneous VDE. What am I going to generate first?
The eigenvalues.
I agree. And so finding the eigenvalues. Here's my, excuse me, characteristic equation. Would that be a lambda plus 1/2 squared? Is it a minus 1/20 equals 0? But that gives me a lambda being equal to a negative 1/2. Ay, ay, ay. You guys never help me. Is that a plus or minus? 1 over 2 root 5.
Maybe.
Oh, these ones are free. Say yay or nay. All right. I'm just going to place faith in them. Let's next find the eigenvalues. Now to find the eigenvectors corresponding to my first eigenvalue, can I just label this lambda sub 1 so I can keep track of it? How about negative 1/2? How about minus 1 over 2 root 5? I think the corresponding eigenvector for that eigenvalue is going to be generated by augmenting with a column of zeros, the matrix A, and subtracting lambda from its main diagonal. Does that give me this? Does that give me a positive 1 over 2 root 5, 1/10, 1/2, and yet again another positive 1 over 2 root 5? You guys, I'm tired. Can we skip a few things? Watch. What do I multiply this term by to get this one is 1 over root 5. But if I multiply this term by 1 over root 5, don't I get exactly that? So is it not true that clearly these two rows are multiples of each other? And that being the case, I think this augmented matrix reduces to something like this, but you guys, I'm serious, I don't want to do a lot of work. How about taking that first row? I don't know, just multiply by 10. It gives me 1 over here. So that give me this. Guys, I'm just being honest. I'm trying to avoid a lot of arithmetic. And if the arithmetic I performed so far is decent, then I think my first corresponding eigenvector, my v1 bar, is simply going to be, would it be this? Wouldn't it be a 1 negative root 5? I don't know, you guys. I just kind of hope we had enough practice with the eigenvalues and eigenvectors. We could do a lot of this in our head. Just tell me if I'm wrong. Now, I think for the other eigenvalue, lambda 2 being equal to negative 1/2 plus 1 over 2 root 5. You guys, what's going to happen? I'm going to get the same darn augmented matrix. I'm just simply going to get a sign change along the main diagonal. But again, bark at me if I'm writing too fast. So I think to find the corresponding eigenvector, I've got to deal with this augmented matrix. I said sign change along the main diagonal. But here too, clearly using the same logic, my second row is a multiple of the first. And I even think I can clean up the first row if I simply multiply that first row on both sides by 10. I said on both sides, I meant multiply the entire first row by 10. I think I get this. Which means the corresponding eigenvector I'll call v sub bar 2. Well, I shouldn't say it is, but one representation of it should be, is it a 1 positive root 5? And if you guys are okay with that, that basically said that my complementary solution is simply going to be, actually, I've lost it. My eigenvalues are negative 1/2 minus. What would be this? Plus C2 times e to the raised to the power of the other eigenvalue. Times t. Times the corresponding vector 1 comma root 5. And the underlying fundamental matrix. This is going to be nothing more than this 2 by 2 matrix. E to the power. Negative 5 times that. And then e to this power. Yeah, I know, I'm sorry. It's a lot of writing, isn't it? And root 5 times the same thing. Yeah, guys, I'll stop for a second. So, no tricks. I do think that's a fundamental matrix. And having said that, I think we're now ready for the non-homogeneous case. You guys, so far it's just pretty straightforward stuff.
Yeah.
Now, I do think in the non-homogeneous case, my job is to find a particular solution. And I think a particular solution is going to look like this. Actually, you tell me. It's going to look like
X fundamental matrix.
fundamental matrix times
U bar prime.
where I gotta confess, U bar comes up from looking at the system where I got U bar,
Times V bar.
U bar prime
Prime.
times
Fundamental matrix.
the fundamental matrix equals.
V bar.
Yeah, that column vector. Yeah. So to find my U bar, I better take that second equation and solve for U bar prime first. Yes.
Let's use a calculator.
What's that?
Let's use a calculator.
It's not such fun.
Did you even look at your phone?
I did. What if you're on a desert island?
I won't be worried about that.
What are you gonna pass your time by?
Playing with coconuts and talking to volleyballs.
You ever heard that the American general during World War II, Omar Bradley? He was an American general in the European Theater War, and so he'd always be flying around these lumbering DC-3s. And every time he'd land somewhere, he'd have his staff scour the area to try to look for, just sheets of integrals, so that when he's on that lumbering plane with all the time, he's got something to keep his mind going. So on a desert island, you really wouldn't be doing this? Where are we going? Separate islands. So I think, oh, you guys, I gotta stop talking. You tell me how you want to solve the system. I mean, do you want to use inverse matrices? Gauss-Jordan elimination? Cramer's rule? I'm being honest, you guys. I gotta look too. What would be the
I
easiest one?
think inverse matrices would give
Yeah.
product of squares, perhaps, when you calculate the determinant. at the end of the-
So the homework does, they use inverse matrices in the homework section.
I just think because all these coefficients are similar, maybe inverse matrices is the way to go.
The one that he didn't assign.
7, 6
Yeah,
bars.
I took a look at some of it.
I was doing this like a Gauss-Jordan elimination.
So you did most of it with the Gauss-Jordan.
I did all of them with Gauss-Jordan.
Can we just be different? Can I use inverse matrices?
Yeah.
So I think with this equation down here, I simply have that U bar prime is equal to the inverse of the fundamental matrix times my V bar. But that means I've got, let's compute the inverse of the fundamental matrix.
Yeah, this is exactly what the book or the solutions guide does each time.
So the product down here, along the main diagonal, is that gonna be a root 5? E to the negative t? Minus a negative root 5 times e to the negative t. So that's the determinant now. And I'm going to multiply by the same darn matrix. It's just that I'm going to pull out, I should say pull out, but just interchange entries along the main diagonal. Would that give me a root 5e to the sum of those two bounds? And down here, would that give me e to the negative 1/2 minus 1 over 2 root 5? Now, along the non-main diagonal, I'm going to have the same entries. E to this power. And root 5 times e to this power, but it's negative. It's just along the non-main diagonal to have a sign change. And I multiply my b bar, you guys, was 12 times 0. Now, in terms of evaluating this product, actually I won't. Downstairs, let me clean up a little bit. Is it going to be 1 over 2 root 5, even negative t? You guys, it looks like the arithmetic's not going to be that bad. Let's just crank this out. I think multiplying this 2 by 2 by the 2 by 1, I'm going to
So-
get another 2 by 1, right?
Can I complain about your handwriting really
Yes.
fast? You've got an integral in the instead of a square root in the second row of that matrix.
That was a square root.
All right, that's better.
This is why the pens run out.
Yeah.
So I got 2 more.
give you another 2 weeks, we'll finish this problem.
Yep, nice.
I just want you to be happy. And you guys multiplying out, it's not gonna be that bad. Is that just gonna give me a 12 root 5 times 7? And downstairs, actually, you know what? It's the same darn thing. I just get a sign change with the second term in the exponential position. Wow, you guys, it looks like my coefficients are going to clean up really nicely. Actually, looks like a lot's going to clean up really nicely.
Yeah.
Does that give me, is that a positive 6e to the, yikes. Is that e to the positive 1/2? Plus 1 over 2 root 5t. And then another 6e to the positive 1/2, but minus 1 over 2 root 5 times t.
Now, why did you do that? Look at exponents.
Because I can. Bring this upstairs to e to the positive t.
Oh, I see.
Now remove parentheses, I think the 1/2, or excuse me, negative 1/2 t plus my positive 1t gives me a positive 1/2 t. So everybody happy with my u-bar t?
That's U bar
Yeah,
prime.
good. I'm not either, because I think it's u-bar prime. I got to anti-differentiate. But you got to confess, anti-differentiate is not that bad. And I think that tells me that my u-bar t is going to be nothing more than shoot. Not that bad. You guys, I can't do it. Is that a 2 plus 2 root 5? No, I think I made a mistake. Hold it. I did make a mistake. Common denominator is 2 root 5, I put it upstairs. Cheapers. But I think this is going to give me a root 5 plus 1. You guys be honest, is that okay? Michael?
So how do you approach the integral for like the first one? Like with the term in parentheses, the 1/2 mil?
Here's what I did. To be honest with you, all I did was I divided both sides by the coefficient. Divided this thing by its coefficient. Because when I differentiate e to at, don't I get a times e to t? If I differentiate e to the at, don't I simply get e to the at times the a? And so when I anti-differentiate at the time, I simply divide it by the coefficient. It's just that if you try to find a common denominator, you multiply top and bottom by root 5. You get root 5 plus 1 all over 2 root 5. I just simply invert it and multiply it. And playing exactly the same game downstairs, I think I'm going to, I think I'm going to be left with this. Instead of 6 times another fraction, okay, I've got to slow down. Is it root 5 minus 1? E to this power. I think I'm ready. Because now I think my particular solution can be expressed as nothing more than the product of my fundamental matrix times my u-bar, which I think in this example is, gosh, it's been too long. It's been a few minutes. My fundamental matrix is the following. E to the negatives at negative root 5 e to the same power. My next column is e to the different exponent. And then root 5. I think times e to the same exponent.
Your t looks like a lambda.
My 2 looks like a
Your t looks like a lambda.
Where?
Alright.
I missed my computer. And my u-bar is simply what you see up top. Gosh, did anybody can simplify that? Alright, I'll stick with it. Is that a 12 root 5? Or stuff? E to this power. Same thing down here, but with a sign change downstairs. And a different exponent. Guys, isn't this gonna be relatively easy?
No,
Oh yeah,
it's not
I
that
think the numbers
bad.
are turning out really, really nice. After all, if you dot this very first row with this single column, don't look at the coefficients, just look at the e's. You know, here, adding exponents, the 1/2 root 5 completely drops out. Even here, the 1/2 root 5 completely drops out. That's not bad, is it?
No. Not
And
at
so
all.
I think that
Yeah.
means.
Whoa. Yeah. No, never mind.
The one half's also. Yeah.
Yep, everything drops out.
So there's,
Well, the 1/2 will also drop out, right?
you know what, you guys, I didn't even see that.
Yeah.
Oh, that is so beautiful.
Yeah, it's
So it's
just
just
really
the
nice.
coefficients.
It's just e to the, yeah, e to the t squared, I think, right?
So does that give me a 12 root
Yeah,
5
is it?
Yeah.
Not times the time?
over 1 plus root
It's just
5
constants?
plus
Because we're looking for
12 root
concentration.
5
That's why.
over root 5 minus 1. Downstairs, okay, you guys, I experienced the same wonderful phenomenon.
So,
And I simply have,
can we always expect some sort of nice cancellation when we do it like this, or? Because I mean, I remember on the quiz that we did this weekend, it everything canceled pretty nicely.
it often does. Yes.
All right.
And I think as far as my coefficients are concerned, downstairs, would there be a negative 60? 1 plus root 5. And then a positive 60 over root 5 minus 1. But this is the same thing as the following.
Perhaps you shouldn't have simplified the coefficients earlier.
You know, I wanted the same thing. Like, for example, if I had rationalized the denominators, that might have been nice. But I still think this is bad because no writing. Multiplying this one by that denominator, this one by that denominator, I can immediately see cancellation with some of the terms. So it's not as bad as it looks. So you guys, does this give me 120? Does it give me another positive 120? Oh, I lost my train of thought, hold on. Those cancel, I'm left with a positive 60 twice. Ah, such nice numbers. And finally, you guys, I guess I can state my solution. I guess my final solution is going to be that x sub c, excuse me, I misspoke, I didn't mean c. My solution is going to be c1 times some stuff. You guys, this is important. So I'll let I write. Is it negative 1/2 minus? So 2 minuses. And I got a 1, is it negative?
1 negative root 5, yeah.
Now the other one should be a c2e to the negative 1/2 plus 1 over 2 root 5 times t
No, it's just,
times 1 over root 5.
Yep. ooh,
And then plus
ooh,
1/21.
ooh, that's bad.
Why?
You put a fraction in your vector.
Oh my goodness.
Yeah.
You didn't see that.
I just have a question for the particular vector. Where did the denominators go? I'm just not seeing the simplification there.
Oh, Daniel, I have no idea. I really fouled that up. When I did the arithmetic in my head, I completely neglected the denominators. You guys, what should this denominator be? 6. Yeah, I think it should. Because I get root 5 squared minus 1. My apologies. I made the same mistake down here. So I guess in the end that gives me 2 20s?
Yeah. Oh,
Maybe it's
20s.
Oh, did I make another mistake?
It's 4 on the bottom.
No, 5 minus 1 is 6.
I believe it.
So 230s.
So I tell you not to trust me. Does that get you 2 30s?
Yep.
230.
Okay, you guys, big sigh of relief.
Your 3 is sideways.
Big sigh of relief.
All right.
Yes.
Are we done?
Well, you said.
Yeah, I don't know if you guys remember this, because I took it off the screen, but I did have some initial value conditions. I'm not gonna turn it back on the screen, but it's on my computer, I'll take it. I did indeed say that initially tank 1 contains 50 grams of solution, whereas tank 2 contains 10 grams. So I think what I'm suggesting is the following. X1 divided 0 is equal to 50. And X2 divided 0 is equal to 10 grams. What is this going to allow me to do?
Allow you to find a constant for
Find
each of
constant
those.
C1 and C2.
Yeah.
So I think when I come in and substitute 0 for T, and then 50 and 10 for X1 and X2, I think it gives me the following. So 50 and 10 is going to give me, is that C1 times this? Plus C2 times this. Plus my 30 column vector. Or maybe use my math B skills. Does that suggest C1 plus C2 is equal to 20 and negative root 5 C1 plus root 5 C2 is equal to negative 20? Now I'm multiplying the first equation on both sides by root 5.
You don't really have to. You could just factor out the root 5 and divide it, and then it's just really simple addition. You get rid of the C1s right away.
I agree. Either way you
Yeah.
look at it, it's fine.
Okay.
So if you want to do that instead, that gives me negative C1 plus C2 being equal to a negative, I don't know.
Negative 20 over root 5.
Negative 4 times your 5.
That works, yeah.
And my first equation is just this. So when I add these two equations together, does that tell me 2C2 is equal to 20 minus 4 root 5? So C2
2C2. Oh,
is going to be half of that.
Yeah.
So that could be 10 minus 2 root 5. C1, however, is going to be obtained by multiplying the second equation by negative 1, adding it to the first. That would give me C1 being equal to the following. 10 plus 2 root 5. Oh, you guys, I am finally done. Now I see that my x bar and t is equal to my C1 times e to that power. Times this column vector plus my C2, which is simply this constant, times e to this power, times this column vector, plus my 30 column vector. Wow, you guys, that only took us half an hour. That's not bad at all.
Was it really half an hour?
I don't know, gotta keep track.
It's all really easy though, right? I mean,
But that's my point. I mean, you guys understand the individual sub-processes at this point. So it's
Yeah.
kind of nice how we're using matrices and little silly stuff in chapter 2 and chapter 3 and actually solving some equations. Chris?
You should give an example where they have to use complex lines.
Yeah, or maybe I should have made up an example where it's a defective matrix. It's really because of the application of coverages.
or it's a 3x3.
No,
Yes. So did I see why I give you long hours on Friday with mine?
Yeah. Nice.
Anybody have any questions for Oasis?
Yeah, I got a question.
Yes, Chris.
Or do I? This gave me-
Well, that is your question, whether or not you have a question.
Eigenvectors. You said you could use one eigenvector, or rather, you were looking for one eigenvector corresponding to a
Yes, I did.
particular eigenvalue. Can you scale that eigenvector and still correspond?
Absolutely.
Okay.
Absolutely. To be honest with you, at the end, is that going to be amount to you at this stage of the game, pulling out the coefficient, absorbing C1, if you wanted it to, if you wanted to.
Yeah.
And if you did, it's simply going to change the value of this C1, so that in the end you get the exact.
Right, what I was asking was that it still maintains the status as an eigenvector.
Yes, yes, absolutely. I think there's infinitely many eigenvectors corresponding to that eigenvalue.
So there's a vector space associated with the
with the
eigenvalue
eigenvectors.
minus the zero.
Thank you, you captured it, minus the zero vector. Anybody else? All right. If not, I am going to introduce you today something that is just going to so beautifully facilitate solving differential equations. Maybe not systems anymore. I'm getting away from systems. You want a really nice, convenient way to lose points.
Ooh, Laplace transforms?
Mispronounce the French word. So you guys understand how snobbish mathematicians are. We just think we're the best because we're the foundation of all the sciences. No, I'm serious. There's a lot of snobbery in mathematics. So many mathematicians just think they're the... I was in graduate school. I came across a mathematician by the name of Dieudonné? Dieudonné? Anybody know what that means in French?
I don't know.
God-given.
Wow.
No, it's awful. So anyway, you guys, one day Laplace, as a mathematician, was working on something called potential theory, and he came up with these really nice transforms, Laplace transforms, and he used them in his potential theory work, whatever that is. And along came an engineer, who mathematicians usually look down on, and an engineer said, wow, I can use these to solve differential equations. Let me just Laplace both sides of dE and play with it. And he did, and he was solving differential equations that way. And he was using it as a professor. I think he was a professor at the time, I think. His name's Heaviside. You ever heard of Heaviside? Oh, really? Yeah, the Heaviside function comes from his name. And the mathematicians found out Heaviside was doing this. And they got so pissed off at him and said, you can't do that, you didn't prove it works. So the mathematician sat down and proved it does work. And so now everybody's using Laplace transforms to solve these.
So is he a little bit on the heavy side?
I have no idea why the name is what it is. By the way, it's spelled this way. So not with a Y. So you guys, treat this as a man-made definition. The Laplace transform of a function f, which is a function in t, is going to be described, or defined I should say, as an improper integral of e the negative st f of t dt. Now once I evaluate this integral, the t's are going to go away. They're going to go away because I'm evaluating a proper integral. The s will not. So what I end up generating is a function, I'll call it big F. But it will be a function in S. It is truly a transformation from one space to another. Now, what you guys need to know are some basics. You need to know the basic underlying Laplace transforms. So if you guys don't mind, I'm going to go through a few today.
Wait.
Yes, I'll wait.
So S is also a variable?
Yeah, as a matter of fact, with this transformation, it's like I transform from a space of functions in T to a space of functions in S.
And so this is a partial.
It's a partial.
Integral?
I'm not sure why using the word partial.
Because I don't know, I'm not sure how to treat S in that case.
Well, in terms of the integration process, because S is not the variable integration, T is, I think you treat it just as a constant with the integration process. Because again, the variable integration is T itself. By the way, you guys, I'm sorry if I'm talking too fast. I should have slowed down for a moment. Yes or no? Do you think this Laplace transforms a linear transformation?
Yes.
Oh, absolutely. You take L of f plus s, excuse me, I misspoke. L of f plus g, it just means this is addition in here. Now I can separate the two integrals, two individual Laplaces. Something else. If I multiply f by c, well, there's just a c factor here. Does that get pulled out of the integration process? Clearly, Laplace transform is indeed a linear transformation. But let's Laplace something special. Let's Laplace. How about an exponential function of this form? I think what that's going to give me is this improper integral. Let's do which is nothing more than this. Which is nothing more than 1 over a minus s, e to the a minus st.
I'm confused.
I am too. I think I'm so wrong. Why?
Oh, I wasn't even.
Oh, before that, Chris? Don't look
Oh,
at
so
there yet.
that's not, I'm sorry, that's not the vector